Well, good afternoon, good morning, or good evening, depending on where you are in this world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, your moderator for the event, and I welcome you. We have a great webinar on tap with some really interesting information, but before we get started, we do have some housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to access it on demand. Following the presentation, we'll be sending out an email that will include a link so that you can access the webinar. And we are taking questions from the audience. So if you have a question for either of our panelists at any time during the presentation, don't wait, just use your GoToWebinar control panel, submit your questions, and then we'll take probably about 15 minutes near the end of the presentation and go over those audience questions. Okay, with that, we'll go ahead and get started with today's webinar, which is Compliance and Audit Readiness, the DevOps Killer. Our speakers today are Anne-Marie Fred, who is DevOps Lead Commerce Platform at IBM's Digital Business Group, and David Jenkins, who is an IBM Distinguished Engineer in the Office of the CTO US Federal. Welcome to you both. Thanks for joining me today.
Thank you.
Thank you.
David, I think you are actually going to kick us off, so I'm going to go ahead and turn it over to you and let you do your thing.
Okay, great. Thank you. So compliance and audit readiness, more important than ever, especially in a whole variety of different markets. If you want to play there, you have to prove that you are compliant with whatever their regulatory types are. So Anne-Marie and I are going to talk a little bit about how DevOps and compliance can work together, and how that this does not have to have a negative impact on your DevOps. So starting off here, we'll just take a look at really why compliance is important, why security is important. If you just look at the number of data breaches, 1.4 billion in 2016. I wish we could say that number was shrinking year over year, but it's actually growing year over year. And also just looking at the cost to organizations who are breached. So whether it is a per record lost type of a cost, or the average cost of a data breach being $3.62 million, it's really something we cannot afford in our industry to ignore. And yeah, that's a trillion with the $6 trillion is what is projected to be the annual cybercrime damages in 2021. I'd like to think that we're going to work harder, work smarter, and figure out how to reduce that value. But this is just some of the key items that tells you why compliance and audit readiness are important. Next.
All right, so the business value of DevOps is well known and proven. One of the things that we quote pretty often is the 2014 State of DevOps report, where they have data that shows that high-performing IT organizations are twice as likely to exceed their profitability, market share, and productivity goals, and they have 50% higher market cap growth over the years among public companies that they attract. So, why does this happen? Why does DevOps lead to better outcomes? Well, first of all, we have lean product development practices. We have lean management practices and continuous delivery. And these work together to get you better software delivery in terms of speed and quality, a healthier working culture, and increased job satisfaction. And that's how we get improved business performance out of DevOps. It's an interesting story. One of my coworkers actually put together a portfolio of companies that advertise themselves as leaders in DevOps, and they did significantly outperform their competitors in the market. That's not investment advice, it's just a fun story. But there are some challenges that are specific to DevOps and continuous delivery. First of all, a lot of our processes around compliance and audit readiness used to or still assume a waterfall development model where there's a long period at the end of the development cycle, weeks or even months, just for testing and compliance and audit readiness activities. But with DevOps and continuous delivery, we have frequent deployments, maybe even daily deployments. So we simply don't have that long lead time in most cases before release. We also have very short-lived services. Services may, start up and then shut down within the course of a few days or weeks. So anything that requires a lot of manual effort for onboarding and offboarding individual services is problematic. We also have few technical gates to production. Anybody can go use their personal credit card to start up a server, right? So technically, it's very easy to put new services into production. So you have to have new organizational procedures in place that govern what your developers are allowed to do. Next, DevOps intentionally blurs lines between development and operations. And in many companies, especially startups, smaller companies, or web native companies, the development and operations teams are the same people. And finally, the change advisory board used to be a very slow process. Maybe they would meet once every couple of weeks or once a month. And some DevOps organizations have gotten rid of the change advisory board entirely. Then they have to invent new processes that take the place of the functions that used to be handled by the CAB. Other places have found they need to automate and streamline the change advisory board to keep up with these frequent deployments. Go here. So how do we reconcile these? How do we get the advantages of DevOps while still keeping up with our compliance and security and audit readiness requirements? And for this, I'll hand it over to David.
Okay, so one of my favorite slides, quite simple, but often very confusing when you talk to people. They seem to think that these two things, security and compliance, are one and the same. And they're obviously closely related, but I think just understanding what that relationship is. So compliance is not security. Security is the protection mechanisms, whatever they are, that you put in place to ensure that hardware, software, data is not stolen or damaged. And what compliance is it's really a measure of that security. It's a proving that you're secure, and you prove that by evaluating your security against a particular set of policies, standards, regulations that will apply to a specific industry. So different industries have different regulatory types, different control sets, etc. And compliance is really just the process of saying, okay, well, based on this guidance from this industry, how secure are we? And here is just a short listing of a handful of probably the most well-known standards and regulations. So in the federal market, we have FedRAMP. We also have FISMA. We have things like the DISA impact levels. If you also look, there's CJIS, which is FBI's criminal justice information security policies. There's international policies like standard regulations like ISO, and then ISO has tons of the numbers after it of all the different control sets that you evaluate yourself against. There's PCI for payment card industry, HIPAA for health, SOC, and then of course GDPR, which is a new law in the EU that talks about primarily about privacy and privacy of end user customer type data and how you manage and control that. And so as you look at all these different standards and regulations, what's key is to think about that prior slide. Security is not compliance. Compliance is actually just the proof that you're secure, again, according to a particular set of controls. And each of these standards regulations then defines what does it mean to prove you're secure for HIPAA, for health insurance type information. What has that industry decided? This is what's important. And so then you look back to say, okay, what are we doing around those particular types of security controls? Next. Okay, so how can we help teams by standardizing on the terminology, on collecting requirements? The simple little graph on the left is just an abstract way of looking at the number of controls and the different type of controls and overlap between the different regulatory type control sets. So in the prior slide, we talked about all the different regulatory types, and certainly it wasn't all, it was just a sampling, as is this. But what we're looking at is just the number of controls and how many of them have this strong correlation across the different regulatory types. And typically what we've done in the industry in the past, and we're working really hard at IBM to change that, especially the way we do things, is you look at this in a very siloed fashion. You say, oh, okay, well, you know, ISO is the international standard, so yeah, pretty much everyone's going to have ISO. So your offering team goes off and evaluates themselves against ISO, and they tick that box. And then along comes the sales team and says, hey, we're trying to sell this into the health industry. So how do we line up against HIPAA? And so now the security team goes off, or security and compliance team goes off, and they evaluate themselves against HIPAA. And they do it in a very siloed fashion. Most of these, the way these controls are set up and even the way they're overlapped does not make it easy to quickly understand what's available in one, or where you may have already answered that question, and so you end up kind of doing it again and again. And what we advise is that you leverage a very broad control set first, such that you can evaluate yourself, your particular offering, against that control set that says, okay, here's what I've implemented, here's what I've done, here's what I haven't done or partially done. And now you have this baseline viewpoint of here's where I sit. And then when you're asked to, well, tell me how you stand up against PCI, you don't have to go back and look at everything. You can use mappings between PCI and that broad baseline to do that. The other thing is that when you're looking at the set of controls that you're going to use as your baseline, this broad set of controls, and really any set of controls, has this error factor in it that is the interpretation error. And whether you are the developer, or whether you're at operations, or both, or you're the customer, or you're the auditor, or you're the regulatory body, unfortunately, many of the security controls are not as prescriptive as we would like them to be, and therefore it's based on an interpretation. And so you could be audited one year by auditor X, fill in the blank who that is, and the second year you decide to use a different auditor, and they come in, and when they do the audit, all of a sudden they're finding all different kinds of problems that you didn't have before, because their interpretation of the control is different. It's one of the reasons that we focus on using the NIST SB 853 control set as our baseline set of controls, because it's a very prescriptive set of controls. It doesn't leave a whole lot left to interpretation. Many other controls leave it to interpretation. This gives you a baseline that says, this is exactly what I mean by this particular control and what's expected, and so you end up with less problems on that. We look at automation, just reducing errors in manual documentation, the ability to capture evidence in real time, generate documentation through tooling. These are all processes and steps that you can put into place within your organization to reduce the number of errors. And that's really what DevOps is largely about, in that you're removing that human factor and you're putting in automation. And so when it comes to your security and your deployment processes and development processes, absolutely, but don't lose sight of that automation factor when it comes to showing your compliance and demonstrating that security. Leverage automation tools to help you through that process faster. Next. Okay, so also security does not equal privacy. So we know what security is now. We understand what it means to be compliant, or what compliance is. It's proving you're secure. Privacy has to deal with your ability to determine how data is being used, who has access to the data, what data is shared, and how do I remove that data. So for example, as I mentioned before, GDPR is one of the big ones on privacy. Is a new law that went into effect in May of this year. And it requires that anytime you collect data from a consumer, that you tell them exactly what you're collecting it for and how you're going to use the data, and not in 16 pages of teeny tiny print legalese, but in very simple, easy to understand language. And then also, they have the ability to come back and say, I no longer want you to keep my data, I want you to remove it. And you're required by law to remove it within a certain amount of time. And any organization that you've shared it with, it is your responsibility then to go to that organization and ensure that they also remove the data. Next.
Great. So the good news is that if you're following DevOps best practices, you will significantly improve your security posture. And how will we do that? First of all, one best practice is 100% unit test coverage. That means that as developers are writing new software, they're testing every line of code in some way. And so if somebody accidentally or intentionally inserts code that's fraudulent or has errors, you're much more likely to catch that very early on in the process. A second best practice is behavioral tests that even non-technical people can understand. So these are the business rules for your system. And again, if somebody introduces code that breaks one of your business rules, you're going to detect it very early before it ever gets to production. So if we're talking about specifically security tests, we also have some very nice test automation suites that are available to us. Two examples are IBM AppScan and Application Security on Cloud. And these can do a number of things to detect security problems for you. They can do static code analysis and look for patterns that are likely to be security problems. They can do dynamic black box testing, where they try to hack into your user interfaces for you. And they can detect known vulnerabilities in the open source packages that you're pulling in to develop your software. So if you just install these test automation suites and use them, which is really usually not very difficult, you're going to significantly improve your security posture. And another thing that really helps is infrastructure as code. So this is where you define your infrastructure using code, something like Ansible or Chef, and this works best for cloud deployed systems, but you can do it for managing the software that's deployed to your bare metal servers as well. And what we want to have is immutable infrastructure, which means that instead of having somebody log in and change one of your systems by hand, you let your infrastructure as code system stand up new servers primarily. And since it's generating those new servers from scratch every time, you know what the configuration is on those systems. There's no guessing involved. And the changes are only possible via a code change. The good thing about that is that code changes are code reviewed by other developers. And we can actually enforce that in our system, so it's impossible to deploy a change to production without an approved change. Another thing we do is that we prevent manual SSH access into our servers, which blocks a lot of attack vectors for us, and again, prevents intentional or unintentional changes that could break our system. And again, like I said, we have our code review changes, which is the second set of eyes on every change. In terms of privacy, another best practice I wanted to talk about, something that we do within IBM, is a global privacy assessment. And this isn't a DevOps practice in and of itself, but it definitely dovetails nicely with what we're doing. So prior to the first delivery of software to production, and also as needed anytime there's a change that will impact privacy, we ask our teams to fill out a global privacy assessment for their service. And this is reviewed by data privacy experts, actual humans, so that we can ensure that our systems are complying with the applicable rules and regulations. It is a survey that asks information about what personal data you're collecting, what it's used for, where is it stored and processed, what access controls you have in place. So for personal data, it's determining if you have any sensitive personal data, and we have a very clear definition of what that means, what data is sensitive according to different laws. And we also have another kind of personal data, which we call pseudo-anonymous data. That's things like the IP address or maybe an internal identifying number that's not personal data directly, but you can derive who this person is and track them using that information. And we have different controls on that type of data. And in terms of how it's used, this gets into the purpose, right? Like David was talking about with GDPR. What purpose are you using the data for? How are you informing your users of that purpose? Is consent needed? In some cases, we need consent, explicit consent from the users to do certain kinds of processing of the data. In other cases, we have a legitimate business reason that we need to use the data. For example, we cannot have a website without logs of IP addresses, right? We need that for security purposes in case there's a breach or something like that. So we need to answer the questions, is consent needed? How do we track whether people have given us consent to use their personal data for this purpose? And what are your downstream processors? So where are you sending your data after you collect it? Are you sending it to a log aggregation service? Are you sending it to a monitoring service? Have they agreed to handle the processing of the data in line with the consent that you have to process it? And that can be one of the more complicated things to set up. This global privacy assessment, when we were doing it 2 years ago, could take up to 6 to 8 weeks, but we've managed to streamline this process so that for certain cases, maybe you have no personal data or you have very limited, pseudo-anonymous data that you don't need consent for, and our blanket statements are already covering you, you can get through this process within a couple of days. So we've really modernized this practice. Another thing that DevOps practices will tend to push you in the direction of is to have a lot of microservices using their own databases. Maybe they're using NoSQL databases where you don't have the very structured queries. And this can make it more difficult to get a hold of your personal data and how it's being processed. So one of the things that we've done is really reduce the number of personal data repositories that we have in our systems. So a powerful motivating factor for this was GDPR with the data subject access requests. For GDPR, you have to be able to tell people what data you have on them across all of your systems. You have to be able to update, correct, modify that data on request, and you have to be able to delete it in many cases. And for things that aren't deleted, you have to have like a log retention policy on them. And so we made it a requirement that any system that processes personal data needs to be able to link into our data subject access request processing systems. And this overhead was a powerful motivating factor to reduce and centralize the number of personal data repositories that we had. So now most of that data is centralized in our user profile and billing systems. And other systems avoid copying the data locally for their own processing. Instead, they access the data using API calls when it's needed. And of course, the APIs are very fast. And the API calls also ask what purpose the data is being used for. And the API will only return the data that we have permission to use for that purpose. So it's a very nice service that we've sort of centralized for all of our applications. Back to you, David.
Okay, separation of duties or segregation of duties. This is typically one of the things that people pop up and say, well, hey, if I'm doing DevOps, how can I possibly do separation of duties? The whole idea is I've got basically one team of people doing everything, and I don't necessarily have that separation. And actually, that really couldn't be further from the truth. I think DevOps makes it easier to enforce the separation of duties, primarily because of all the automation that's put into place. So if you take a look at the little chart down there at the bottom, just briefly breaking down what exactly is separation of duties. So in this particular example, you have the role administrator. The role administrator is the one who goes in and basically says, here's the privileges that are assigned to this particular role. And then you have the role assigner, and this is the one who says, here's the users that are given this role. You break those into two separate roles and two separate people so that you don't have one person who can come in and say what the privileges are going to be and put themselves in the role. It requires this whole idea of at least two people being able to review and approve everything that happens. And so your purpose is, well, you're trying to manage conflict of interest. You're looking to prevent any single person being able to act independently or alone and compromise security or game the system. You're restricting the amount of power that any one individual might have by breaking that into multiple pieces. And so I think kind of the hard part about the separation of duties or segregation of duties is analyzing the various roles that you have and ensuring that you understand, because you may have, say, 10 different roles. Well, many of those roles, the same person can have those roles. But there's a few that you need to ensure that the same person doesn't have role A and role B. And so those are really the ones that you need to identify and go through. And the whole premise, again, is how do I ensure that you can't game the system? An example around for like auditing. So if I have the ability to administer the system and I have the ability to administer the audit logs or the audit events, then I could potentially game the system by going in, turning off audit events for a particular type of administrator event, then using my administrator privilege to go in and do changes I probably shouldn't be doing, and then go back in and turn that event logging back on. And now no one's the wiser to know exactly what's been done. So that's really what the separation of duties is looking to prevent. And so you take the task and you break it into multiple people, and you include things like automated testing, automated configuration. When you do deployments, you have built-in audit testing, issue tracking, so that there's always a record of everything that's been done. And typically it requires multiple people to approve something before it can get all the way through the process. Next. Here's what not to do. So when I was looking around on the internet just the other day, I came across this funny little cartoon here just about, well, hey, our budget won't allow us to buy segregation of duties software package, so the auditor said we all have to press the key together. Trust me, this is not what they mean by segregation or separation of duties. Next. Okay, so methods for separation of duties. So here's some examples, some things to consider. Application solution functions. You look at dividing these functions into multiple groups. Typically, they don't want users and administrators to have the same roles. You need different users to have user type roles, different administrator type roles. So you would have, like in a prior example, I said, system administrator and the audit administrator should typically be two different types of roles. And again, you're always looking at this. Okay, if I have both roles, does that enable me to somehow game the system? And if it does, then make sure that you can't have both roles. Or if there's privileges, the same type of thing. Multiple privileges that are in a single role, you might need to break that out into multiple roles to prevent me from gaming the system. You can also look at ensuring that different individuals perform different support functions. Again, this is just breaking it into pieces. Developers don't create the code, configure it, and deploy it into production. They create the code and they then have peer reviews, and after the peer reviews, there's a pre-configured system that the configuration of that also went through peer review, and then you're going through automated testing, and if it doesn't pass the testing, and the test scripts themselves also went through peer review, and so you've got multiple people all along the way ensuring that nothing just passes seamlessly through based on one person's action. Looking at security personnel who administer systems, making sure that they don't have access to both the audit functions as well as the system administrator or privilege type functions. Automated testing. So adding automated testing, quality assurance, code drift detection, these types of things can be added into your DevOps pipeline. It reduces the fallibility of human interactions. Making mistakes, butterfingering, miskeyed strokes, etc. But also where you have sensitive areas of code, you can add additional testing directly in your pipeline. And see, these are things that would be more difficult to do if you weren't using DevOps and you were going more through the manual process. It would be easier to forget to do things like that. And so this allows you to pay special attention to those, add that additional testing in. When you're looking at your infrastructure, as my colleague mentioned just a moment ago, using configuration tools, configuration checking tools, using pre-hardened images, so that every time you deploy the infrastructure, it's basically deploying it brand new. Every time you deploy the solution, it deploys it brand new. And so things that potentially someone would have slipped in will immediately get overwritten. A lot of the automation tools for checking configuration will auto-correct anytime they find a problem, or they just simply reload the image to ensure that it's always based on the standard image that, again, already went through the multi-person checks before it even got there, or the idea of using sidecars for containers. Next.
All right, so here are some of the things that we've done on our DevOps teams for separation of duties via access control and limited authorization in particular. The first one I mentioned was the code reviews and approvals. We've made these required by our continuous integration pipeline. So most of our teams are using GitHub Enterprise now, and you can configure that so you literally cannot merge code without an approval from a second person. And we've made our HR managers, in our case, the system administrators, the ones who configure those repositories, so the developers can't go in there and turn that setting off themselves. Another thing that we have is a simple and clearly documented process for quickly revoking access to systems. So if somebody leaves the company, or even if they leave the team, how can we very quickly offboard them from anything that they had access to before? We also limit access to any data to those with a need to know. And anything that's going to be used as an audit log is not editable and can't be deleted by anybody in the company. A lot of this is actually, we'll send it off-site, so it's safe. Another thing that we do is we're separating the administrators of the access controls from the code reviewers and approvers, and separating the administration of the auditable events from the administration of the pipeline itself. We also use credentials, so you can track who was doing each action. So we use our personal credentials if we need to make any manual changes. And again, those are really minimized, but those are using personal credentials where we have to do it. And we use functional IDs for automated changes in the pipeline. And when we get those keys, those access keys for the functional IDs into the pipeline, we actually have our managers own those functional IDs and the credentials and encrypt them themselves before they put them into source control. We also have the configuration of our build and deploy pipelines in source control. And we do have some groups that use a special tool for building and deploying, maybe something like Urban Code Deploy. And in that case, they're limiting the ability to configure that deployment system to a different group from their development team. We also have secure authenticated APIs for any operations that involve non-public data or any operations that make any changes to the system. And we have separation of duties via lockdown of our production systems. We have most of our services are using immutable systems that are just created and deleted as needed every time you make a change. And like I said, we prevent SSH access entirely into those systems. That means we can't make manual changes to the production systems. Another thing that's a best practice is if it is possible to make manual changes to some of your systems, set up a way to detect those changes. Any change that was manual or wasn't configured through your normal pipeline should be flagged as something that needs review for audit purposes. And as I mentioned before, infrastructure as code is very helpful here. It's worth the investment in terms of the visibility and control you get. So basically what you've seen is how we've built these controls into the processes that our DevOps teams have in place as part of their normal development processes. So they can still deliver changes on a daily basis in many cases without having to do many manual checks. And security and compliance activities should not be about doing the minimum and just checking a box. We need to be thoughtful about the ways that we can meaningfully reduce the risks in our systems. Here I've summarized how some of the core DevOps practices reduce the risk from changes to your system. So if you look at automation, it prevents risk because with test automation, it's harder to break the system in the first place. And with deployment automation, you have a low rate of failures due to changes. Automation makes it easier to detect problems because you have third-party automated tests and scanning tools that provide additional safeguards for you. And in terms of recovery, you can recover much more quickly if your systems are self-healing, if you automatically block attacks to your system, and if you have automated failover when systems go south and stop responding to requests as expected, you can switch over to another system automatically. For monitoring helps us prevent problems because we learn to understand what normal and exceptional states look like for our system, and we can set up alert thresholds that will wake somebody up in the middle of the night if something starts going wrong. And we also can recover more quickly because we can quickly page out the developers who are responsible for those systems. And then when they've put a fix into place, whether that's an infrastructure fix or a code change, our monitors let us validate that the recovery actions have returned the system to normal like we expected. For logging, that prevents problems because, again, we gain an understanding of what normal and exceptional states look like, and we can set up log analytics that can alert the DevOps team when something is not going as expected. And then in terms of recovery, again, we can validate that the actions that we took to recover from problems have returned the system to its normal state. And logging is, of course, also very helpful for forensics purposes. If there has been an incident or a data breach, you're going to need those logs to dig into what has happened. Another DevOps practice is fast deployment. So in terms of preventing risk, frequent deployments are shown to result in a low change failure rate because each change is very small. Deployments can help us detect problems because we can graph when deployments happened and show exactly when changes went in that may have caused problems that we're seeing in our system. And in terms of recovery, if we've automated our deployments, we're not afraid to deploy a fix. We can do it very quickly, and that means our mean time to recovery is very short. In many cases, we can make a change to the system and recover from a problem in half an hour or less. All right, back to you, David.
Okay. So automation, collecting documentation. Remember the earlier slide just about the difference between security and compliance. Compliance is proving you're secure. How do you prove you're secure? Typically with audit evidence, evidence that you're doing what you say you're doing, documenting what your policies, procedures are on how you manage and control things like your configuration settings and baselines. What is the process by which you go through and take new code and push it through and out into production? How do you go about doing that? What is the process in which you do it? How do you ensure that one person didn't game the system? How do you know where the code came from when you deploy it? You know, even looking at things like code signing. All these things are steps along the way that you can and in most cases should be doing. And there's a lot of attention being paid toward automating more and more of the DevOps life cycle, the ability to, you know, as Anne-Marie just said, take a change that you've just pushed into production, find that there's a problem, and push an update to it within 30 minutes. And that wasn't like a frantic, oh my gosh, we have to get this done, jump through all kinds of hoops to do it, but actually doing it just through the typical process. So as we look at applying that automation to the DevOps process, also look at applying the automation to capturing the evidence that shows you're following the process. The audit records all along the way, whether it is as you go from in the diagram there is just kind of a sample of a DevOps lifecycle from end to end, and each step along the way, you're capturing evidence, you're capturing audit records that say, you know, so-and-so just submitted this code change into the code repository. And when that code was built, it then went through this series of automated testing. And here's the output from that automated testing. So all these things along the way, you have put into place the security around your DevOps process, and the automation of your compliance is really about putting into place the ability to capture the evidence and the audit records that prove that you're implementing the way you said you're going to implement these particular security controls. So there's a sample here just of some of the audit records that are typically requested. These in particular came out of the 853 control set. One of the controls in there defines here's the audits that you should be able to, the audit events that you should be able to create. These events aren't specific to DevOps, but it doesn't take too far of a stretch to take a look at those and figure out how do they apply and what are the other types of events that I should be collecting along the way, along that flow, so that anytime I am audited, and audited is verifying that you are compliant. So my compliance is proving I'm secure, and my audit then verifies that the proof I have actually does that, and that I have everything in place and all my documentation order. Well, you can pretty save yourself a lot of time and pretty seamlessly go out and instrument additional audit capabilities so that that information gets collected for you. Compliance assessment evidence. So use a repository for that evidence. Don't, you know, put it in 3, 4, 5 different places. Don't go out and say, well, yeah, of course it's available. Those audit logs are there. You just go to that particular system and get them. Well, as Anne Marie was just saying, hey, every time we deploy a new system, guess what we do? We deploy infrastructure as code, so it deploys a brand new one. So if it was logs that were locally stored, they're gone. So how are you capturing the logs for when things change, for when you do a new deployment, for what happened before that deployment? Ensure that you capture this evidence and you put it into a location that makes it easy to get to. Internally within IBM, we have a tool, acronym SECT, that we use to build our compliance documentation to help us with that automation, and also to enable us to automatically collect evidence and associate that evidence to the specific controls, so that when an auditor comes in and says, okay, we're going to audit these 25 controls, we can then very easily say, okay, great, well, here's the evidence for those 25 controls. We've already got it. It's in a single repository, and it's super easy to collect just the pieces of evidence we need for the specific controls that we're being audited on. So apply that DevOps automation thinking to your compliance roles. Next.
And the good news is that you get some very helpful compliance and automation documentation for free when you invest in DevOps. You have your source code change and code review history stored for you. You have your build, test, and deployment logs. You have offsite audit and transaction logs from your running location. And you have all of your monitoring data. So are compliance and audit readiness really DevOps killers? The answer is no. Instead, DevOps exerts a healthy pressure on your company. It forces you to modernize your processes, simplify them, focus on real risk reduction, and automate as much as possible. We all need to move from slow, labor-intensive compliance gates towards more streamlined but equally effective continuous compliance. Any final thoughts on this, David?
I would just reiterate, as we move towards continuous compliance, just the whole aspect of taking all the lessons learned really from DevOps and how DevOps came to be and the level of automation that was put into place, and take that and use it to your advantage to automate your compliance. Compliance is not it's not security, it's proving you're secure. So it shouldn't end up being a major feat at the end of a year-long project to then go back and collect all the documentation that proves I'm secure. Automate it, put it in the pipeline, do it along the way, and then at any point in time, you can just look at it, it's all right there.
Great. And we do have a couple of links here if anybody wants to follow up. There's a website here about security and governance from IBM. We have some services around that. And also, if you want to learn more about DevOps, we have a couple of books that are for free at this event management page, DevOps for Dummies, and put in the Ops in DevOps. We have a little bit of time for questions.
Yeah, we've gotten some questions in so far. If you do have a question for either one of our panelists, though, don't hesitate. Go ahead and use that GoToWebinar control panel and submit your question, and we'll take a look at them. First question for you, David, is when enterprises are trying to modernize their development processes, do they get overwhelmed with the compliance and audit overhead? And where do you tell them to start?
Absolutely, they always get overwhelmed. It's typically kind of scary at times when they get in and they look at the number of controls that they're being asked to demonstrate that they're implementing. And what I tell them is kind of the same message we've been giving here: is automate, automate, automate everything you possibly can. And a lot of security is, one, about, well, do you have it in place? And then two, can you prove it's in place and that it hasn't been touched or changed or modified or tweaked. And when it is, you have a record of the fact that it was by who. So it's all about, auditing what you're doing and having processes in place.
All right, great. Next question is actually for you, Anne-Marie. What are some of the changes your team had to make to improve personal data privacy management?
One of the fun things that we had to do was around cookie consent. This came primarily out of the GDPR requirements, where we have to ask our end users what type of data we're allowed to collect on them. So we had a massive project where we had to centralize our cookie consent tracking into one system. We use I think it's called Telium for that. So every single web page had to put a plugin in place that would check to see if a person had consented to us collecting personal data and what level of consent they gave us. Did they tell us that we're allowed to track their, actions through the sales funnel, which we would love to do if we have permission to do it, or did they say, collect the absolute minimum amount of data on me? And then we store that information so you're not getting that pop-up 1,000 times. And then, like I said, our systems that use that personal data have now linked into our consent tracking system so that they can query to see what they're allowed to do in terms of tracking you as you go through the system. Another good one was changing GitHub configuration, like I described, and then of course reducing the number of personal data repositories. I lost count of how many systems we actually deleted or features we actually turned off because they were maybe not very important systems, and they they were tracking things that we hadn't thought of as sensitive personal information before, but they did have some personal data in them, and so in our case, it was easier just to turn them off.
Okay, great. Next question, I guess it's to either one of you. What is the recommendation for the broad set being discussed?
I think that was for the controls.
Yes, I think you're right. Yeah.
Yeah, is NIST SB 853.
Yeah, I remember that was one of the big
Right.
That was one of the big challenges in educating developers, right? Is what does this terminology mean and how does that translate into real actions?
Yeah, and the 853 controls are, as if you look at all the other control sets from these different regulatory types, 853 has done a pretty good job of being quite prescriptive on what needs to be done. Internally within IBM, we've gone through and reviewed those controls and provided what we call the the summary control or the net of what does this control mean? Because typically the way these things are written seems they were, sorry if you're an attorney, but they're written by lawyers. Cross every T and dot every I and restate it 6 or 7 times in a slightly different way just to make sure there are no loopholes left in what we're asking for. And because of that, you end up having to read the control 3, 4, 5, 6 times, and you're going, oh, that's what they're asking for. So we've netted it out internally. If you have multiple offerings that you're working on, I would highly recommend that you do that once and not make all of your developers try to figure out what that legalese means.
Yeah, I've seen that boiled down to a lot of checklists and questionnaires and things like that, right? To try to help people understand what these really mean.
All right. Great. So we are about 6 minutes to the top of the hour. I think we have time for 1 or 2 more questions. So the next one, how do you best work with auditors who are not familiar with DevOps? Have you found that they sometimes don't understand the evidence you're presenting? Maybe David, if you want to take a crack at it.
Sure. Yeah, I think I responded to that one in question section. Typically auditors know what evidence they need. They know what the regulatory type, whatever you're being audited for, they know what the control is, and they know what the possibilities are for how you might go about implementing such a control. So when it comes to leveraging DevOps and working with the auditors on this, it's largely about explaining the process, explaining your implementation of the particular control. And once you have a good explanation of your of the control as far as how you've implemented it through DevOps, then it's just a matter of showing them the evidence that you have that in place.
Okay. All right. So then the next question, are there recommended code scanning tools?
I would selfishly recommend IBM's code scanning tools.
Good answer. Good answer.
Yes, if you search for IBM Security or AppScan, you'll find those. There are also good code scanning tools available that are open source and free. Like I know for Node.js, there's now an npm audit tool that does a good job of finding known open source vulnerabilities. If you go to the OWASP website, they have a nice suite of tools out there that are open source scanners, again, for known vulnerabilities. And there's a lot of third-party tools out there that will check, but they tend to be domain or programming language specific.
All right. And actually, speaking of OWASP, we have one more question. Do you see value in OWASP for security guidance?
Absolutely.
Yes.
Yes, yes, and yes. Again, they're pointing out here are, some of the most critical security risk that are out there. You always end up with this level of kind of interpretation as far as, well, within my industry, how did they phrase that requirement, right? But looking at and using OWASP, especially the OWASP top 10, absolutely beneficial.
Yeah, I think the OWASP top 10 document should be required reading for all development and operations staff, honestly. So like the best 2 hours you can spend in terms of security training and awareness. Another thing actually that I've found to be very helpful in terms of education is when you get these security tools in place and they're scanning your code and telling you what the vulnerabilities are. Most of them are actually very good about linking to the background information, what the vulnerability is, how to exploit it and test your system to see if it actually applies to you and how to remediate it. So if you have at least one person in each of your teams who becomes sort of a local security subject matter expert, they can invest the time into really understanding those reports.
All right, great. Well, we are about 2 minutes to the top of the hour, so we need to close out the Q&A part of today's webinar. So thank you to everybody who did submit questions, and want to also remind the audience that today's event has been recorded. So if you missed any or all of it, you will be receiving a link via email after the event that will take you to the event on demand. And the webinar is also going to be living on the DevOps.com website. So if you want to just check there, all you have to do is go to the homepage and click on webinars on demand, and it should be sitting there waiting for you. There's also a ton of other webinars there, both upcoming and on demand. So take a look around. Hopefully there'll be one or two that pique your interest. And right now it just leaves me to thank Anne-Marie, Fred, and David Jenkins both for joining me today and giving such a great presentation. I appreciate it. Thanks for joining me.
Thank you.
Great. Well, this is Charlene O'Hanlon, and I am signing off. Have a great day, everybody.